All right, so this is going to be the last video of Unit 1. So we're going to start on the review page on the back of your packet. Okay, so it says a high school athlete runs 1.00 times 10 to the 2 meters in 12.20 seconds. Okay, so when you're looking through things, we don't really have a whole lot of equations right now. We have velocity equals displacement over time, and we have speed equals distance over time. Okay, basically the same equation, just velocity is a vector, speed is scalar. Okay, but for this instance, it's not going to really matter because you would still plug it in the same, so it doesn't matter which one you use. The key is knowing what you have. So 1.00 times 10 to the 2 meters, that would be my displacement. Now, if you want to go ahead and fix that, you can. Okay, so 10 to the 2 means that's going to be a bigger number, so you can just move that decimal to the right 2 times. So that's the same thing as saying 100 meters. Okay, and then 12.20 seconds, so that is going to be my time. And then what is my velocity in meters per second and kilometers per hour? So velocity is going to be my question mark. So V equals D over T. So that's going to be 100 divided by my time, which is 12.20. And that is going to come out to, my velocity is going to be 8.20 meters per second. Okay, so there's one answer right there. Okay, now I want to know it in kilometers per hour. Okay, so we have our conversions. So when you're going from kilometers per hour to meters per second. The way I remember that is if you want to go from an hour to a second, you're getting to something smaller. So you're going to divide by 3.6. Okay, versus if I want to go the other way, so if I want to go from meters per second to kilometers per hour, I would multiply it by 3.6. So since I'm already in meters per second, what I'm going to do is I'm just going to multiply this number by 3.6, and that's going to give me 29.52 kilometers per hour. So there is your other answer there. Number 2, a person walks 13 kilometers in 2 hours. What is the person's average velocity in meters per second and kilometers per hour? So I have my displacement. You could say distance as well. In this case, it doesn't really matter. If you only have one value, it doesn't really matter. I have 13 kilometers, and my time is 2.0 hours. So that means I'm looking for my velocity. So velocity is going to be displacement over time, so 13 over 2.0. And that's going to give me 6.5 kilometers per hour. Okay, so there's one answer right there. Now, if I want that in meters per second, what I'm going to do is I'm going to divide by 3.6 now. And that's going to give me 1.81 meters per second. Okay, so again, if you're ever unsure and you start to kind of panic, just kind of start labeling what you have and then see what you can plug in. Now, number 3, using the data table below, during what 1 second long time interval is the car the slowest? I want to know during what 1 second period is it the slowest and is it the fastest? Now, one thing I am seeing is you have to be careful. This is position. This is not displacement. That does not mean in 0 seconds I covered 30 meters and then 1 second I covered 30 meters. That's just showing you where you are. So that says at 0 seconds I'm at 30 meters. At 1 second, I'm at 30 meters. At 2 seconds, I'm at 35. So that's what we're talking about. So if I want to know who's the slowest, I would look at the gaps. Okay, so 30 to 30, that's going to be 0. So I'm going to go ahead and bet that's the slowest one. 30 to 35 would be 5. 35 to 45 would be 10. 45 to 60 would be 15. And then 60 to 70 would be 10. So if I'm looking for the slowest, I'm going to say that 0 to 1, that 0 to 1 time frame is going to be the slowest because you didn't move. Then if I was looking for fastest, that's definitely going to be the 3 to 4 second range because that is when you jumped up by 15 meters. So that's what we're looking for there. You just got to be careful and not get position and displacement mixed up. Now, number 4 says using the table above, find the average velocity of the car. So I'm looking for velocity. Okay. In the time interval between 0 and 2 seconds. So I know my time is going to be 2 seconds because from 0 to 2 is 2. And I want to know how far did I get in that 2 seconds. So what is my displacement? So at 2 seconds, I'm at 35. And at 0 seconds, I'm at 30. So what's my gap? So 35 minus 30. Okay, so remember, if you ever want to find your displacement, it is your final position minus your initial position. So 35 minus 30. And that's going to give me a displacement of 5 meters. So if I want to find velocity, velocity equals my displacement, which is 5, divided by my time, which is 2. And that's going to give me 2.5 meters per second. Number 5, suppose a car travels at a constant 10 meters per second. So that right there gave me my velocity or speed. In this case, it really wouldn't matter. How far would it move in 1 hour? So I've got 3 different times. I've got 1 hour, 1 minute, and 1 second. Now, if my velocity is in seconds, I cannot have my time in hour and minutes. I'm good on the second part, so I can go ahead and solve that. So my t would be 1 second. And I want to know how far it can get. So displacement is your question mark. So 10 equals displacement over 1. So 10 times 1, you multiply both sides by 1. Okay, and you get a displacement of 10 meters. So there's one answer right there. Now, if I did 1 minute, okay, you're going to have to convert that to 60 seconds. Okay, so you have to be in the same type of units. You can't have meters per second and then use some time in hours because it wouldn't work. Okay, so I'm going to do the same thing. So velocity is 10. Displacement, I still don't know. And my time now is 60 seconds. So in 60 seconds, I'd be able to get 600 meters. And then last one, 1 hour. What I would do there is there are 60 minutes in 1 hour, and there's 60 seconds in 1 minute. So 60 times 60 is going to give you 3,600 seconds. So I'm going to do the same thing. So 10 equals displacement over 3,600. And you're going to get a displacement of 36,000 meters. Okay, so that's your answer. Now, when you look at the equations, we have the V equals D over T. So I'm going to kind of go over that trick again. Okay, so if you have the circle, you have V equals D over T. If you're looking for something, so if I was looking for D, I would cover it up. So cover it up, and that would be velocity times time. Now you can do the same thing for the speed one. So speed equals distance over time. Now if say this one I was looking for time, I would cover it up, and that would be distance divided by speed. So that's how you kind of do that circle trick. Okay, moving on to the next page, I have a train leaves a station at 0.0 marker, so just saying you started at 0. Traveling with a constant velocity at 36.0 meters per second. So I gave you velocity, so 36.0 meters per second. Okay, how many seconds later, so it means I'm looking for time, so there's your question mark, will the train pass the 1,620 meter mark? So that is your displacement or distance. So 1620.0 meter marker. Okay, so I'm looking for t. Okay, so remember V equals D over T, so cover up the T. Okay, so I'm going to plug it in, so 36.0 equals 1620.0 over T. Okay, so there's two ways you can do that. You cover up the T, or you always know you can switch these bottom ones, the bottom if you're looking for a variable on bottom. So it's actually going to be 1620 divided by 36. Okay, so T is going to come out to be 45 seconds. All right, then B, what is the velocity of the train in kilometers per hour? So I just found it, well, I actually just found time. I just want to know what the velocity is in kilometers per hour. So if I'm in 36.0 meters per second, I'm going to multiply that by 3.6. That's going to give me 129.6 kilometers per hour. So there's your answer there. All right, number 7, at 1 p.m., a car traveling at a constant velocity of 94 kilometers per hour. So my velocity is 94 kilometers per hour. Okay, is 17 kilometers to the west of your school. Where will it be at 3:30 p.m.? So I know my time from 1 p.m. to 3:30 p.m. is going to be 2.5 hours. I'm looking for displacement. Now this is where it kind of gets a little tricky. So the way you got to look at it is, let's say that right here is your school. And so from here to here, so we'll say point A is where you're starting. That is 17 kilometers away or west of your school. Then you start driving even further west. Okay, and you end up at point B. So we want to know what is this displacement right here. But when I ask the question, it says, how far are you basically from the school? So whatever I find here, I'm going to add to that original 17 because I started originally 17 meters away from the school. Okay, so I'm going to do V equals D over T. So 94 equals D over T, which is 2.5. So I get a displacement of 235 kilometers. Okay, now that's not my answer. That's just how far I went during that time. I still want to know how far I am from the school. So what I'm going to do is I'm going to add that 17 because that's originally how far I was from the school. So that's going to be 252 kilometers. Now be careful. If we give you directions, usually there for a reason, I'm going to throw west in there because you were telling me that you ended up 252 kilometers west. Okay, so that would be the answer for that one. So 8's basically the same thing, but now I started 17 kilometers east of the school. Okay, so what I'm going to do now is I'm not going to add them now. What I'm going to do is I'm going to take my displacement. It's going to be 235 minus 17. Okay, which is going to mean that I ended up 218 kilometers west of the school. Okay, because you had to go 17 meters to even make it to the school, and then you'd have to go 218 meters more to make up for that 235. Now, when would it be at your school? So again, your school's right here. Okay, and you started east of it, and that's 17 kilometers. So I want to know how long does it take me to get that 17 kilometers. So my velocity is still 94 kilometers per hour. Okay, my displacement is now, I just want to know how long it took me to get that 17 kilometers to the school. So I'm looking for time. Okay, so I'm going to say 94 equals 17 over t. That is going to come out to 0.18 hours. Now, you could leave it honestly like that, how long it would take you to get there. Okay, when it says when would you be at your school, you could do the time if you wanted to. You could do 60 minutes, okay, times 0.18 if you want to. And technically it'd be 1:11 p.m. But if you can solve for time, either one's going to work. Okay, number 9, describe what's going on in the motion of the 4 walkers shown in the 4 curves in the figure below. Assume the position, positive direction is east. Okay, so east is right here, so that means all this is positive going up, and that makes this negative going down. And your reference point is the corner of High Street. So right here at the origin 0. Okay, so if I were to look at A, if I were to describe what's going on there, okay, I would say it starts at the origin. So starts at origin. And it's definitely going to be a positive motion. Okay, so it's going in the positive direction. And I would say that is a uniform velocity. Meaning that your velocity is constant, it's not changing. So it starts at the origin, it's going in the positive direction, it's going east, and it's going at a uniform velocity. Okay, then B, what's happening at B? I'm going to say it starts at a negative position. Okay, it's going a uniform velocity. It's still going in the positive direction, so I'm going to go ahead and kind of abbreviate this now. Positive direction, because it's going towards the east. Okay, and then it is going to be uniform as well. It's still a constant velocity. Now, if I were to compare those two points, A and B, it looks like A is a little bit steeper than B. Okay, but I'm not really asking you to compare the ones. I just want to kind of describe the motion. But if I were to describe those, I would say A is going a little bit faster than B, just because that slope looks a little bit steeper. Then we have C. Okay, so if we look, our slope starts off strong and starts to flatten out. Okay, so that means that we are slowing down. If your slope's starting to get flatter, that means you are slowing down. So slowing down, we're going in the negative direction or you are going west. Okay, either one will work there. And then it started at the origin. So starts at origin. Then D, we're going to say it starts at the positive position. So starts at positive position. Okay, it has a negative direction, okay, because it's heading west, so negative direction. And that's going to be a uniform velocity because you have a constant line, so it means nothing is changing there. Now, if I added like one more line, so say I did something like this, so say I said E. Well, if I'm not changing position, I would just say that this E is staying at a positive position with no motion. Okay, so that's something you could see as well. Okay, going on to the next page, 10. So we're going to sketch one. Okay, so for this case, what I'm going to do is I'm just going to draw a line. I'm going to do one big graph for this one. So remember your positives up here. Oops. So So your positive is up here, your negative's down here. We're gonna use some different colors here. So starting at a positive direction, so we're gonna say A, we're gonna go with the black color. Starting at a positive position with a positive velocity. Okay, so starting up here, it doesn't matter where, as long as you're starting above the x-axis. Okay, and we're gonna have a positive velocity, so it's gonna kind of look like that. Okay, then B, starting at a negative position with a smaller positive velocity. Okay, so I'm gonna use a different color, I'm gonna use blue for B. So starting at negative, I want to slower though. Okay, so I'm gonna start down here and I'm gonna make a slightly more flat line. I probably could have drawn that a little better with A, but B is gonna be a little bit flatter than A was. Okay, so remember A is up here. Okay, B is down here. We started a negative position and our velocity is short or smaller. Okay, then C, remaining at a negative position. So that means they're not moving. Okay, but they are at a negative position, so it'd be like a flat line right there. Okay, so that would be C, and let's try a different color. Starting at a positive position with a negative velocity. Okay, so I'd start up here, doesn't matter where you are, doesn't matter if you crisscross any of them, and you're just going at a negative velocity, so that's what that would look like there. And that's the gist of basically drawing out. You're just kind of describing motion basically on a graph. Okay, 11, describe the differences between constant velocity, average velocity, and instantaneous velocity. Okay, so remember constant velocity, so constant, that is uniform motion. So uniform means it is not changing, and it can be positive or negative. Okay, so what that's going to look like on a graph is it's going to look something like this. Now it could be positive or negative, but it's a constant straight line. So you can find the slope of that line and you're good. Now, if I did average velocity, that is usually the velocity between 2 points. Okay, so velocity between 2 points. So if I had a graph that looked like this, so I go up, over, up. Oops, it just switched up on me. So up, over, and then down. Okay, so let's say I want to know the average velocity between my start and my beginning. So basically what I'd do is I'd find these 2 points and I would just plug that into slope formula and find the slope of that line, and that's it. Okay, now instantaneous, okay, that is the velocity at a given time. So velocity at a given time. So I want a certain time. So usually what you'll do is you'll see graphs that look like this where they're speeding up. And if I want to know the velocity right here at that point in time, I can't find the slope of a curved line because it's always changing. So what I would do is I'd draw a tangent line that bumps up next to it like that. And I would pick any 2 points on that line and then just solve for slope. So that is the difference between constant, average, and instantaneous. Now, number 12, use the graph above to answer the following questions. Now, this is where you gotta be careful. You have position and you have time. So remember, slope equals velocity. Okay. At 3 seconds, which cyclist is ahead? So that would be position-wise. I want to know who's further up on the y-axis at 3 seconds. So at 3 seconds, I have A right here and B right here. So B is going to be further up because it's further in the y-axis or further in position. Okay, just be careful when you're reading these graphs. It's real easy to flip-flop those A and B's. Like you totally get it, and then your eyes play a trick on you, and all of a sudden you think A is on top and B is on bottom. So just be careful when you're reading it. Which cyclist is traveling faster at 7 seconds? So that's what we're looking for slope. We want to know who is steeper. That is going to be A. So that means no matter what time it is, whether it's 7 seconds, 3 seconds, 5 seconds, A is always going to have the faster velocity because it's a steeper slope. They'll never have the same velocity unless their slopes are the same. C, are their velocities equal to any time? No. We just talked about that. So you would see a parallel line. Okay, so you'd have to see a graph that looks like this where they're both parallel. Okay, that's the only time you'll ever see velocity the same. D, what is happening at the intersection of A and B? So that does not mean they have the same velocity. That means they are just at the same position. So if I were to look at this graph, I would look at A has a steeper slope. Okay, B actually gets a little bit of a head start, but it's going a little bit slower. So at 5 seconds, that means A is passing B. So it's overcoming B and going forward. Okay, so that answers that question. And then 13, if a car's displacement is increasing every second, what is happening to its velocity? Now this one's been getting some confusion. So that means if I said 1 second, I covered 5 meters. And then the next second, still 1 second. Now you covered 6 meters. And then the next second, now you covered 7 meters. That's what I'm talking about when you're increasing displacement. You're increasing the amount of ground you covered each second. If you're increasing that, if displacement is going up, velocity has to be increasing as well. Now, if you want constant velocity, that means you'd have to run 5 meters every single second and nothing ever changes. So that's what constant velocity would look like. Number 14, a car drives 30 kilometers east, so watch out for directions. 2 kilometers west, so that's a big thing, they're conflicting. And then 15 kilometers east again. And then what is the distance? So remember, distance does not care. Like if you ran that or walked that and I asked you how far you went, you would not just subtract 2 just because you went west. You would tell me how far you actually went. So distance, all you got to do is just add them up. 30 plus 2 plus 15, and that gives you 47 kilometers. Now displacement's a little different. Okay, displacement cares about which way you go, so direction matters. So I would go 30 kilometers east, turn around and go 2 kilometers west. I'm going to minus that 2 because you can't just add east and west like that. And then I turned around again and went 15 kilometers east again. Okay, and that's going to give me 43 kilometers. Now be careful. Distance doesn't care about direction, so this would be scalar. No direction, just a number and a unit. Now 43 kilometers, I ultimately ended up east. So I still need that, my answer right there. And that would be an example of a vector. Okay. If the trip lasted 0.5 hours, so I just gave you time, what is speed? So speed is distance over time. So I'm going to choose between A and B. So I'm going to use what I found in A. So 47 divided by my time, which is 0.5. So 47 divided by 0.5 is going to give you 94 kilometers per hour. And that's your answer there. Now velocity uses displacement over time. So my displacement would be 43 over my time, still 0.5. Okay, and this would give me 86 kilometers per hour, and that's ultimately east. So you still want to make sure you put that in there when you're talking about velocity and displacement. Now convert both to meters per second. So I'm going from kilometers per hour to meters per second. So I'm going to take that 94 I got originally, divide by 3.6, and you get 26.11 meters per second. Velocity, I'm going to take that 86, and I'm going to divide that by 3.6. And that's going to give me 23.89 meters per second, and I'm going to keep that east in there. Okay, number 15, a plane travels 460 kilometers an hour for 1.25 hours, slows down to 300 kilometers an hour for 1.1 hour, and then speeds up to 500 kilometers per hour for 0.75 hours. What's the average velocity? So remember our equation is V average equals total displacement over total time. Now, if I gave you a problem that was simpler than this, okay, which you will probably see is, say this was just kilometers, 460 kilometers, 300 kilometers, and 500 kilometers. So what I would do is I would just add up all those. I would take 460 plus 300 plus 500, and I would divide that by the time. So 1.25 plus 1.1 plus 0.75, and that would be your answer. That's it. That's if I give you displacements and I give you times. You has to be displacement and has to be time. This one I didn't. Okay, so this one is a little bit more of the trickier one. Okay, so let me erase this real quick. We'll go back to what we had. Okay, so my velocity one is 460 kilometers per hour, and my time one is 1.25 hours. So that means I don't know displacement and I need it for the equation. So remember, this is where you can do V equals D over T. So what I would do is I would take this V, 460, equals D, I don't know, over time 1.25. So 460 times 1.25 is going to give me that displacement, which would be 575 kilometers. Okay, so you need time and you need displacement in order to find average velocity. So let me clear this up. So we found our first displacement. Now we just got to do it for the next ones. Okay, so my velocity 2 is 300 kilometers per hour. My time 2 is 1.1 hours. So I'm just going to take that 300 times 1.1. So displacement 2 is 330 kilometers. And there's part of that one. And then I have velocity 3 is going to be 500 kilometers per hour. My T3 is going to be 0.75 hours. So I'm going to take that 500 times 0.75. Sorry about that. Displacement 3 is going to give you 375 kilometers. So now I have all my times. I have all my displacements. Now I can do what I originally did when I just talked about displacement and times. So what I'm going to do is I'm going to take 575 plus 330 plus 375 over my total time, 1.25 plus 1.1 plus 0.75. And that's going to give you 412.9 kilometers per hour. And there's your answer. 16, what does slope represent on position versus time graph? We've already talked about that. Slope is equal to velocity. Okay, what is the main difference between a vector and a scalar? Again, vector is anything with a direction. Okay, so that can be velocity, that can be position, that can be displacement. Okay, those are all things where direction matters. Scalar is no direction. Okay, so that could be things like speed, distance, time, mass, anything that's basically just a number in a unit without a direction, that would be an example of scalar. Okay, next one, 18, define the following terms and include whether they're a vector or scalar. So we just kind of did that. Let me find mine real quick. So A, the distance, that is just total ground covered. Okay, and is a scalar quantity. So distance is where you just add it all up. And there's no direction. Okay, it's all positive. Okay, and there's no, so you don't have to put a direction on it all. It's just a number in a unit. Now displacement, that is your difference in position. Okay, from start to finish. So remember, it is always going to be your final minus your initial. Okay, so if you need to remember that. Okay, F comes before I in the alphabet. Okay, and that is going to be a vector quantity. So that means direction does matter. So if you see a positive versus negative, east, west, north, south. Now speed. So since speed uses distance, okay, that is distance over time. That is definitely going to be a scalar quantity. Because if distance is scalar and speed uses distance, speed has to be scalar. Now velocity is going to use displacement. Okay, so that is your displacement over time. And if velocity is vector, if displacement is vector, that means velocity has to be a vector as well. Okay, number 19, last one. Draw a position versus time graph of a moving elevator. Use the first floor as a reference point. Okay, that's probably where we're going to start. Up as a positive. The elevator waits on the first floor for 30 seconds, rises to the third floor for 20 seconds, stops for 30 seconds, and then goes to the basement, which reaches 40. So what I'm going to do is I'm going to draw a graph the best I can on here. That wasn't very good. Okay, so if I go down, like here and over. Okay, remember your position is going to be over here on your y-axis. That is going to, we're going to say floors for this one. Okay, so we're going to have first floor, second floor, third floor, fourth floor, 5th floor, I don't think we have to go any higher than that. Now it does cover a lot of time, so actually I'm going to go up by 10s. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. I think that's where it stops. Okay, point is we're going to start, the elevator waits on the first floor for 30 seconds. So that means we're not moving. Okay, so for 30 seconds, it is just going to all get a different color line. I'm just going to go for 30 seconds and stay on the first floor. We're not moving. Then rises to the 3rd floor in 20 seconds. So it's got to, in the next 20 seconds, it's got to get up to the 3rd floor. Okay, so that's basically right here at that 50 and 3. So we're going to go up to the 3rd floor for 20 seconds. So that part's done. Okay, stops for 30 seconds. So we're going to stay on the 3rd floor, okay, from 50 to 80. So right about there. Okay, and then, so rises to the 3rd floor, 20 seconds, already got that. Stops for 30 seconds, and then goes to the basement, okay, in 40 seconds. So the basement's below the 1st floor, so basically I need to get there by 120 seconds. So we're just going to connect that line down there. Okay, so that ends your review video. So as far as graphing goes, we didn't have a whole lot of graph on this review because we had so many in the packet. So if you want to really understand graphing and stuff or see what we can ask, I would really make sure you know how to do pages 21 and 22. Okay, that would be the best review as far as graphing questions would go. And that's it.